simulates our grain elevator. So we're going to put our grain down in the grain elevator. Okay. We're going to create a spark. Okay, so we got to create our little spark in there. We just got a little candle sitting down in here. We've got a little funnel coming out. We've got tubing coming out from the bottom. Okay. Now you can see, all right, if you squeeze a little gently, you get that cloud of dust, but you got to really disperse it to see it. There we go. It's going to be a little dispersion. Okay. Yeah, we don't have a candle right place. All right, let's get some close there. All right. Our little grain dust elevator was working really good last night, I promise. I think our candles burned out a little too much. We're not getting a good spark, so we'll just show you this again. We just like to burn things. We like those less respect. Get it? Tight squeeze. There you go. There's good. So what you're seeing up here is actually the effects for the two that you see. So Galena Park, Texas in 1976. That was actually an explosion that killed 5 people and injured another 25. And then June 8, 1988. So at least to me, not that long ago. I know for many people in this room, that's before you were born, but I remember that day. So there's our grain dust explosions. There's a lot of mysterious sounding mixing going on over here. I think there's something going on over here. Silver mirror. Still mixing? Okay. Rachel, all right. You need to go pee-pee? I'm going to bring up a little more light here so you can see what we're doing. I'm getting a solution ready over here, trying to show you how people used to make mirrors, old-fashioned silver mirrors. Now, the process that they use is kind of messy, a little bit dangerous. We're doing it on a small scale, not dangerous here. But on a large scale, you know, it has some issues associated with it. But they got this really cool-looking mirror they can see themselves in. It's much better than the polished metal that people used to use. Okay, and what we're going to do, this is also known as a tolerance test. This was developed actually as a test for glucose. So see if somebody, for instance, had glucose in, you know, a high glucose level in blood or urine or something like that. We're going to take a glucose solution, a sugar solution. We're going to combine it with an ammonia solution and a silver nitrate solution. And that reaction in a glass container is going to cause silver mirror to hopefully appear in the inside of a flask. So we've got a flask here. This is what we're hoping to plate. We've already got our sugar solution in here. Now, the reason we're taking a little bit longer here, this solution, we didn't want to prep it ahead of time. This is one you want to make fresh, but since over time, it builds up a precipitate that can be explosive. So just in the interest of safety, we decided to wait and mix it, so we apologize for the delay. You can imagine snow on TV. Okay, so what they've got in there right now is a silver hydroxide precipitate, all that kind of weird black stuff you're seeing. And they're just adding something called ammonium hydroxide that's just going to make that precipitate kind of go away. It's going to form a complex that's soluble in solution. So it just makes it go from that yucky brown to a nice clear color. Get there? All right. Just hit it. It takes a lot for that much. Okay, we didn't quite get it all in there, but I to get that laid out. So now I'm going to add this solution to our sugar solution. So the two clear solutions are going together. They're already turning a little bit yellow. You can see I know it's a little bit dark. Okay, and then start swirling that and go right up the front. Now this can take a little bit of time to happen, so we'll kind of watch it and see. Okay, this is what they used to do. They used to take plates of glass, nice clean glass. You don't want it dirty. And they'd mix up a bath of this solution, and they'd dip these pieces of glass down in the solution. So it was really hard to get really nice big mirrors. If you ever seen old-fashioned mirrors, they have that kind of wavy look. That's because once you get the silver on the glass, it's kind of fragile. It's just hanging there on the glass. You have to do something to keep it there. They would coat it, but their coatings weren't as good then as what we have now. It would scratch and break, and so you get to all these wavy lines and these little nicks and pieces in the glass. Now, for the chemists in the room, you probably already looked at the reaction up here, so you see things that are probably familiar. Silver nitrate, there's that line again, that NaOH, that's lime, that's sodium hydroxide. That forms that silver oxide precipitate we had to get rid of. Okay, so we add behind that. Okay, can you see it? Is it looking a little bit shinier maybe? Okay, it goes kind of slow. It's just one of these that just suddenly kind of appears as you're going along. It looks really nasty while you're mixing that kind of brown. Big pot of coffee. Yeah. Yeah. Coffee.
Make it higher. Faster.
All right. So you can see why it took a long time to make those mirrors. They were very valuable. We just like giving Stephen a workout. Okay, we're going to let him keep stirring. Kind of keep an eye on that. Okay, I'm sure he'll let you know what happens. Okay, so we're going to go ahead and move on to the next one. We can get that going, kind of get two things at once. So see how good you are keeping your eyes peeled on two things. This one that we're going to show you is known as a Briggs-Rauscher oscillating reaction. Now, oscillating reactions are really cool for chemists because these are reactions that once you get them going, they keep themselves going. They'll cycle through a series of actions. Now, this one we're going to start with a nice colorless solution, solution A. Solution A has potassium iodate, concentrated sulfuric acid, and some water in it. And we have solution B that's got a whole bunch of other stuff in it. I won't go through the list because I don't know how much it will mean to a lot of you. Now we're going to add solution C. This is that magic peroxide again, the same stuff we used in our elephant tube. So I'm going to go ahead and bring the lights all back up. Okay. And so what it's going to do is oscillate from kind of this nice orange amber color to a nice blue color. So keep your eye on it. It'll do that several times. Now this is really interesting for chemists because it lets us see something about the way these reactions will get themselves into solution in the system. You can't see it now with all the lights on. But basically what we've got going on, we've got some iodine forming in there. So that potassium iodate, we get iodine, and if you've ever seen iodine that you put on scrapes and cuts, it's probably a lot darker than what you're seeing in the amber color, but you're getting a little bit of iodine built up. And that acts as a feeder for another reaction. The other stuff in there uses that iodine to create a pentaiodine. So it puts a lot more of those iodines together, and those turn blue. And then those blue ones act as a reactant for the reaction that goes back to the amber color. So it just sits there, flipping back and forth. These things kind of get themselves into a figure eight as they go. Okay, and that'll go on for quite a while. Okay, we'll let it sit for a while. Apparently with this one you have the silver mirror, you have to hold the pen just right. So we got it to work twice earlier today and now it's being a little stubborn. We'll let it sit for a while. Maybe by the end we'll see if something happens. So